Hello everyone, today we're going to talk about one-to-one functions and their inverses, section 2.9 in our book. So here they have given us the graph of a function. They want us to determine whether or not it's one-to-one. So a lot of us had questions before about what one-to-one meant. So here we go, we finally learned about what one-to-one means. So a one-to-one function is a function that can pass both the vertical line test. Right, a vertical line means it's a function, but then one-to-one means it also passes the horizontal line test. So the vertical line test, meaning if I do a vertical line, I only hit 1 point. And if it is a one-to-one function, when I do a horizontal line, I'm only going to hit 1 point. So you can see in my first example here, this is not a one-to-one function because it does pass the vertical line test, but not the horizontal line test. So this one, not a one-to-one function. Over here, anywhere I draw a vertical line, I'm only going to hit the point at most. I'm only going to hit the function at most one time. And anywhere I draw a horizontal line, even right here down the x-axis, I'm only going to hit the graph at 1 point. So this is an example of a one-to-one function. Again, determine if this function is one-to-one. So if they give us just f of x equals x squared plus 5x minus 7, for example, if they give us a function like this, we can simply graph it and see if it passes the horizontal line test. So here, again, it does not pass the horizontal line test because I hit the graph at 2 different points. So this function is not one-to-one. Next, they have us assuming a function is one-to-one. So, if f of 5 equals 18, find f inverse of 18. Here is the notation that they will describe f inverse of. So, it is very unique. F and f inverse. If I plug a 5 in for my x of f, and I get an 18 back for my y, that means if I plug an 18 into my f inverse, I should get a 5 back for my y. So f and f inverse have a very special relationship where if I plug a 5 in for my x and I get a 18 back for my y, then the flip side of that, if I plug an 18 in for my x of the inverse, I should get a 5 back for my y. So again, very similar here. They told us f inverse of 4 equals 2. So then if I find f of 2, I should get a y value of 4. Okay, so that's a special relationship between a function and its inverse. That is only the case if it's a one-to-one function. So this section all about one-to-one functions, but they will tell you if it's a one-to-one function or not to start the problem. Next problem, they want us to use the property of inverse functions to show that f and g are inverses of each other. So they've given us two functions. They want us to check to make sure they are inverses of each other. Additionally, these are both one-to-one functions. If you graphed them, you would see they're just lines, and they would pass the vertical and horizontal line test. So we already know they're one-to-one. Now let's see if they're inverses. So to determine if they're inverses, we're going to use this rule here, that if I plug f inverse of x into f, I should end up with just an x in return. And likewise, if I plug f into f inverse, then I should end up with just an x. So let me show you what I mean by that. First one, they want you to plug f inverse, which let's just call the f inverse g, okay, into my f function. So that means I'm doing f of, and then instead of x, I'm going to do x minus 3, right? Because I'm doing f of f inverse. They're saying g of x is the inverse, so I'm just plugging that in and see if we can come up with a result of x. So if this is true, this must equal x, so let's check it out. If I plug x minus 3 into my f function of x plus 3, that means I get x plus 3. That means I get x minus 3, right? I'm plugging x minus 3 in for my x, right? I'm plugging x minus 3 in for my x, and then I have a plus 3 left on the outside, and that's supposed to equal x if they are in fact inverses. So now I can simplify. Well, I have x minus 3 plus 3 equals x. So we can see that the minus 3 and the plus 3 cancel. X equals x. Looks like, that should be an x, and then the check mark. Looks like they are inverses of each other. But let's also check that f inverse of f of x gives us x. So that just means I would do g of f of x, in this case x plus 3, equals x, right? It has to equal x if they are in fact inverses. So that just means I take x plus 3, plug it into g, so I get x plus 3 minus 3 on the outside. I still have to carry that minus 3 down. That has to equal x if they are in fact inverses. Again, x plus 3 minus 3 has to equal x. And again, these positive 3 and negative 3 cancel. We're left with x equals x. Again, proving that they are inverses of each other. And finally, this function is given. First, they want us to sketch it, and then they want us to use the sketch to graph f inverse. So I'll show you how we do that. Finally, finding the inverse of f. So the inverse function of f, just given f of x. So first, let's sketch f. I know just by looking at the graph that this is the square root of x, just moved 1 to the left. So I know that I can pick points right around the origin. So for my first one, this is my f of x. This is the original. I'm going to pick some points. I'm going to pick negative 1, 0, 1, 2, and then I picked a bigger one just to show you what's happening further out. So if I go ahead and plug these points in, negative 1, so a negative 1 plus 1 is going to give me 0, so square root of 0 is 0. If I plug a 0 in, 0 plus 1 is 1, square root of 1 is 1. If I plug a 1 in, 1 plus 1 is 2, square root of 2 is going to be a repeating decimal, but it's about 1.4. If I plug a 2 in, 2 plus 3, well, that's going to be square root of 3. That's a repeating decimal, but it's about 1.7. And then if I plug a 5 in, 5 plus 1 is 6. Square root of 6 is a repeating decimal, but it's about 2.4. So that's a 1.7, 2.4, 1.4. So now let me graph f of x. I'll sketch f of x. So the first point is negative 1, 0. The second point is 1, 0. Third point, 1, 1.4. 2, 1.7. And then I went all the way out to 5 just to see what's happening here at the end, and 5 gives me 2.4. So my original function, f of x, looks something like that. Okay, and if you graph that on your calculator, you would see the same result. And one more thing, just to note, I did square root of 2. So the only thing I used my calculator to do in this case was to figure out what square root of 2 is, so I could estimate the best place to put that point, right? Because it was 1.4, so that way to get as close to the sketch as I could, I did it that way. So now they want us just to use this sketch of f to sketch f inverse. So f inverse, right? Remember when I said before, if I plug a negative 1 into my f and I get a 0 back for my y, well that means f inverse, right? F inverse. Now if I plug a 0 in for my x, I should get a negative 1 back for my y. So I'm just flipping the x and y. So then if I plug a 1 in for my x, I get a 0 back. If I plug a square root 2 in, I get a 1 back. Square root 3 in, I get a 2 back. And square root 6 in, I get a 5 back. Okay, so it's just the inverse. So let's go ahead and graph f inverse. They want us to sketch f inverse as well. So that means I'm at the point 0, negative 1. I'm at the point 1, 0. I'm at the point radical 2, which we said was about 1.4, so about 1.41. Then I'm at the point radical 3, which is about 1.72. And then I'm also at the point radical 6, which is about 2.4, so a little bit bigger than 4, and all the way up at 5. Oh, I'm sorry, a little bit bigger than 2, all the way up to 5. So that one is going to look something like that. So we've basically flipped our f of x over the line y equals x, but if that's complicated for you, really all we did was interchange the x and y values to sketch f inverse just by looking at the sketch of f. Okay, so I just switched those functions around. Last thing they wanted us to do is to find f inverse. So to find f inverse of x, I'm going to start with my original function, f of x equals radical x plus 1. And to find the f inverse, you switch the x and y values, just like we did up here with that. So really, f of x, right, we know that means that y equals radical x plus 1, right? That's just function notation for y. So to find f inverse of x, I'm going to switch x and y, and then go ahead and solve for y again. So to find f inverse, I say x equals square root of y plus 1. And now I just have to work backwards to get back to the y to find the f inverse. So first thing I'm going to do is I'm going to square both sides to get rid of that square root. So that gives me x squared equals y plus 1. Right, square root and the squared cancel. And then just move the 1 over. So y equals x squared plus, sorry, not plus, but minus 1 because we moved it over. All right, so this is also f inverse of x is equal to x squared minus 1. And if you graph x squared minus 1, you are going to get this graph, like it's just a parabola. However, the domains must stay the same. So here, see how we did not cross the x-axis? So here on the inverse, we can't cross the y-axis, right? So that's why it starts here when we flip over the square root of x. So it's going to be x squared minus 1, but x has to be greater than or equal to 0. And we'll do more examples of that to really nail down the domain. But they're not asking for the domain here. They're simply just asking to find f inverse. So go ahead, try the example problems that accompany this on the PowerPoint, and we'll talk about this in class tomorrow.